Welcome back to PLS 510. In this section, we're going to talk briefly about the movement of nitrogen in grass legume systems. This is adapted with permission from a 2020 AFGC workshop on getting back to the basics of forage management. That workshop was sponsored by Corteva, and the original presentation was by Dr. John Jennings, professor and extension forage specialist at the University of Arkansas. And I do want to thank John for allowing me to adapt this presentation. First of all, if you want to take a look at nitrogen sources that we get in a grass legume system, we can get rain and snow, we can have organic matter, we can get fertilizer and legumes. Rain and snow contribute a negligible amount, probably less than 20 pounds of N per acre per year, and probably less than that. Organic matter may contribute up to about 30 pounds of N per acre per year. But the majority of the nitrogen in our grass legume systems are either going to come from fertilizer or from legumes. And of course, we prefer to have legumes in our systems because they provide better forage quality and animal gains. They reduce fescue endophyte problems. They extend the grazing season over grass alone, particularly into the summer. But mainly, they reduce nitrogen fertilizer cost through fixation. And I'm going to spend a fair amount of this next section talking about this dynamic where we need to withhold nitrogen as fertilizer from grass legume stands and how to know if we have enough legume in order to do that. First of all, legumes can fix a lot of nitrogen. The legumes are listed on the left, and you can see that the potential nitrogen fixed is in the middle and the value is on the right. Alfalfa historically is quite a good nitrogen fixer. White clover second, or white clover and red clover coming in about the same range, and some of the annuals down below can have a wide range as well. And that value, depending on how you cost out the N, can be quite a lot per acre. If you take a look at studies that have been done where they look at the dry matter yield of fescue clover in response to commercial fertilizer, the yellow numbers are going to be treatments with no nitrogen and varying levels of phosphorus and potassium, and you can see the yields that they achieved on the right. And this is a 4-year average of fescue and clover, primarily red clover and white clover. And below is just going to be the same stand fertilized with 100 pounds of N. And what I'd like to show you is that you can get the same amount of yield with clover and fertilizer, the P and K, as you would with 100 pounds of N. But it could lead you to believe that the clover is fixing nitrogen and giving it over to the grass. In other words, you would say that in mixed stands, legumes fix in for the host plant and then release it into the soil for the companion grasses. But that is not the way it works. And that may be surprising. First of all, let's think back to the nitrogen fixation reaction. And we said it is an energy expensive process for both the rhizobia and the host legume. They do not freely share, legumes do not freely share the fixed nitrogen with grasses because symbiotic nitrogen fixation allows the legumes to grow in a nitrogen deficient environment. In other words, it gives them an advantage over the grass. So where is that fixed N that rhizobia and plant have worked so hard to manufacture? So as bacteroids in the root fix nitrogen, it's used by the host plant, and in turn the host plant provides carbohydrates to the bacteroids, and then we think of nodules as the factory, but not the warehouse. In perennials, 70 to 80% of the nitrogen is in the top growth, and in annuals, up to 90% of N is in the top growth. Looking at that graphically, the nitrogen distribution between top growth and roots of red clover, you can see that, not red clover, it's crimson clover, which is an annual, and we said annuals have about 90% of their nitrogen in the top growth, and that's exactly what this graph shows. And it's graphed or from samples taken between October and May in Texas, Overton, Texas. So 90% and sometimes more are present in the top growth, less in the roots. So then we know that mixed stands with high percentage of legumes can yield like grass plus nitrogen. Let's take a look at this study with 3 different treatments, looking at total above ground N content and the yield and the percent legume stand. We've got fescue plus nitrogen in the left-hand column, fescue plus red clover, and fescue plus alfalfa. And you can see that this is the nitrogen content here in this system and this system and this system up to here. So you can see that in this system, the nitrogen content is mostly in the grass, and in the 2 legume systems, the nitrogen content is mostly in the legumes. Whoops, pardon me. The total dry matter per acre is similar for the fescue clover and the fescue N system, but fescue plus alfalfa out-yielded fescue plus nitrogen or fescue plus clover. But it took 53% red clover or 59% alfalfa to do so. So clearly it's not the grass that is doing the yielding in these systems, it is the legume. So it takes high percent legume to withhold nitrogen and not sacrifice yield. And that's exactly what this study showed. In this case, we've got 53 or 59% legume in this case too, in order to match the yield of fescue plus nitrogen with red clover, and alfalfa actually exceeded it. Now, how much clover do we think we need to have as a rule of thumb in order to withhold nitrogen on a mixed stand? That is a good question, and one that is discussed a lot, but we think it is 30%, 30 or 35%, at least 25% of legume by weight. And when you separate out a grass legume stand, if it's 20 to 30% legume by weight, it's going to look more like 60% visually because of the way that grass plants grow vertically and legume plants grow horizontally. So how does the nitrogen in the legume top growth move to the companion grass? This is how it moves. From the plant, and we said most of it's in the top growth, the animal consumes it, it passes through the animal. So number 1 is grazing. Number 2 is decay of roots and bits of shoots that have been died and fallen onto the ground. And number 3, root contact, direct root contact, and fungi can move nitrogen directly between roots of plants from the legume plant to the grass plant. But the number 1 source and the largest source is grazing. In other words, we have to cycle those nutrients through the animal back onto the pasture in order for those nutrients to be available to the grass plant. So another way to think of it is producing forage from nitrogen fixation is a process. Producing forages from nitrogen fertilization is an event. So let's talk about a nitrogen fertilized mixed stand of grasses and legumes, and we're going to use this stylized figure. So we apply nitrogen fertilizer. One of the first things that's going to happen, nitrogen fixation is going to shut down. The grass is going to benefit more than the legume in that it is a bit more of a vertically growing plant, and so it's going to grow towards the sunlight and shade the legume. So in this case, the legumes are going to use free nitrogen preferentially over fixing nitrogen through the biological process. Adding fertilizer in favors the grass and inhibits nitrogen fixation, and the grasses then can overgrow and shade the legume, which of course lowers rates of photosynthesis. There's less carbohydrate available, and that too will lower the nitrogen fixation that the legume is going to do. So in summary, Most of the fixed nitrogen is in the legume top growth. The two main pathways of nitrogen transfer from legumes to other forages are cycling through grazing livestock and plant decay, and by a large margin, the largest pathway is through grazing livestock. Total nitrogen fixed is dependent on the percent legume stand, the available free nitrogen, and growing conditions. And transfer of fixed N and grass legume systems is a process, not an event. This concludes this section of PLS 510. We'll see you next time.